What's up? Still me, still the great teacher Alcantara, I guess. I guess. Uh, Welcome to another video, and I'm giving this disclaimer already. I'm going to be wearing the same thing for all of the intros because we're gonna do this back to back to back. And for this video right here, I would like to talk about something that is not meant to be complicated, something that I wish for us to easily understand. And we're gonna talk about arcs, arc measure, and arc length. You know what? Let's just jump right into the video.
First off, it is important for us to remember what an arc is so that we will be able to establish the other kinds of arcs later on. Do remember that an arc is a portion or part of the circumference of a circle. It's basically a part of this one, the circle itself. Not the inside, but the circumference. That's the meaning of circumference, by the way. So it's basically the one making up that entire circle, the set of all points. So basically, for an arc, it could be AB, BC, even ABC, or AD, DC, or ADC, or even like ACB, for example. So, first off, the most important thing that I would like to start off with this short recall is that semicircle is something that you have to really remember so that everything will be much easier compared to different concepts in terms of circle. If you know what a semicircle is, it's basically half of a circle from the word semi, half. So in this case, for you to easily identify it, you have to look for the diameter. The diameter here is AC. Always remember that a diameter cuts a circle in half, giving us two semicircles. In this example, our first semicircle is semicircle ABC. And our second one is none other than ADC. So that's our second semicircle. And as mentioned in this definition, we can easily identify it if the endpoints are of the diameter. So as you can notice, both arcs, their names start and ends with the endpoints of a diameter. What differentiates them is the middle letter because, again, when you have two semicircles, they may have the same measurement, but they're two different semicircles. Depends upon the direction. ABC is the semicircle that passes through point B, and ADC is the semicircle that passes through point D. Moreover, you have a minor arc. Minor arc again is an arc that is less than 180 degrees. Major arc is an arc that is more than 180. So to put this in another kind of explanation, a minor arc should not pass through the semicircle, the length of it. It should not pass through the endpoints of the semicircle. Just one will do. While for a major, it should pass through both. To explain this better, for example, AC, right? That's a semicircle. For it to be an actual major arc, it has to pass through C also. So ACB is a major arc. Again, it has to pass through both endpoints of the diameter or both endpoints of the semicircle for it to be a major arc. You can look at it that way. Again, I'm just giving you guys different kinds of ways to look at this one. So now that we're out with the parts of the circle with arcs, now let's go with the arc addition postulate. This one is not complicated. We have to look at definition of terms here. It simply says that the measurement of an arc formed by two adjacent non-overlapping arcs is the sum of the measure of those two arcs. Always remember when we say adjacent, these are things that are next to each other. So in this example, we can say that we have arc AD. Arc AD is our first example, so let's draw it here. Arc AD. And again, when you have the word measurement, in geometry we use the letter M to represent that. So we can say that the measurement of arc AD, sum means addition, so plus, plus. So let's have another one. Let's say arc DE, since it's adjacent. Why is it adjacent? Because they are next to each other. In this case, for you to understand it better, they share the same point, the D. So in this case, again, AD and DE are again, sorry for that. Shout out Mr. Francisco. That means we have arc DE as adjacent to arc AD. And this simply means that ED or DE, any of them will do. This means that this will be equal to the sum of, or the measurement of what arc. In this image, basically, it's from A to E. From A to E, that arc. And the name of this arc will only be using two letters. Why is it just two letters? Because arc AE or EA is a minor arc. So to reestablish this one, we can look at it this way. Let's have another arc. Let's say arc AB. Let's have arc AB for example. Measurement of arc AB. Let's add it to something that's adjacent to it. Let's say we have arc. What's a good arc to use? Say we have arc BCE. So let's say we have arc BCE plus the measure of arc BCE. As you can notice, if you combine these two arcs, it will make up a major arc. Hence, when we showcase this one or put it in one arc in total, we should use three letters, which is either ABE, ACE, or whatever it is, as long as the middle letter is a point that the arc passes through. So this is the measurement of arc ABE. Again, this could also be arc ACE. Either way, that will be true. Again, two letters for the first one because this is a minor arc. Three letters for this one because this is a major arc. To put this into perspective, we can give out values to this one for you to better understand it. Let's continue. Now, next one is, oh wait, yeah. Let's give values, I think. Yeah, we should. Oh wait, sorry. Let's give out values for this one. So let's say we have here, let's say arc AD. This from A to D is, let's say, 45 degrees for this arc. And then let's say D to E is 70 degrees. So we will simply substitute that. So measurement of AD. Guys, please remember, if there's the letter M, when you substitute, you will remove the unit of measurement. Hence, instead of substituting 45 degrees, you can simply substitute 45 only. So you have 45 plus measurement of ED or DE, that's 70 degrees, so plus 70. So therefore, the measurement of AE is 45 plus 70, which is equal to 115. So just to reestablish, since we're using the letter M, measurement of arc AE, we just have the answer 115. But, again, if you write down arc AE, this should be equal to 115 degrees. If there's a letter M, no need for unit of measurement. Okay? That's an important detail that you have to remember. Next, let's try the other one. Let's say that we have EC. I think you can compute this. This is the one thing that I was mentioning. Since arc AE is 115, what do you think is the measurement of EC? To get EC, the one right here, from E to C, you have to remember that this entire thing forms a semicircle. So that means you can get the measurement of EC if you have 180 minus AE, which is 115, and this one will give us 65. Why? Again, it's a semicircle. That's why 180. So this one is 65. You have to mention this so that we will be able to solve for the next example. So I'll erase this part. Again, semicircle, always remember 180, okay? So 65 degrees. Let's say we have AB as, it's a good number. Let's say AB is 35 degrees. So since this is 35 and BC forms a, AB and BC forms a semicircle, so 180 minus 35, 145. So let's say 145 degrees. So AB is equal to 35. BCE, 145 plus 65, that will give us 210. Therefore, the measurement of ABE is 245. And again, if you want to write down arc ABE, this major arc right here, it should be equal to 245 degrees. Always remember, again guys, the semicircle helps us in solving these kinds of examples. Okay? Okay, let's continue with arc length. So for arc length, it's basically imagining like we have two circles, right? Two circles, as you can see in this image on the left. There are two circles, and as you can notice, there's a smaller circle inside. And even though that angle, this angle right here, from B to the center to D, is the same measurement all the time. It will always be 66 degrees. But again, the length will be different. Why? If you look at this, C to the center, E to the center, this is much shorter compared to B to the center and D to the center. Hence, arc length. It's the length of the arc. It's from D to B. That's way different from E to C. It's pretty obvious. You can see which one is longer in this kind of example. So there is a formula for this one. So as you can notice, using this concept, we will be able to understand what arc length is in terms of the formula. So basically, an arc length is the ratio of the arc length, S, to the circumference of the circle, and it is equal to the ratio of the arc measure in degrees to 360 degrees. In degrees, which is 360. That's what I mean. Why is it 360? That's the circumference of the circle. Always remember 360 degrees for a circle. Now, for the formula, as you can notice, it's a ratio. Hence, we have this formula right here. Now, you might be thinking, sir, how did we end up with the actual formula for arc length? We simply manipulated the equation, derived it in such a way that we were able to isolate S. To isolate S, we have to multiply this entire thing by 2 pi r. If you do that, this will be cancelled here, and hence theta over 360 degrees times 2 pi r. So that's what happened. Now, for those who have forgotten, theta is the angle, or in better words, we call this as the reference angle. Meaning, we based off our solution, refer to our solution on this angle, or refer the other measurements on this angle when we are solving. Okay, so to continue, let's use this formula in getting the arc length. So let's have this example right here. The most important part here that you have to remember is that we have r, which is for radius, theta for reference angle. So let's identify them first. So it says find the arc length of AB. So if you have the arc length of AB, to what angle is it related to? It's 25 degrees. So our theta is equal to 25 degrees. Next, our radius, always remember guys, it's given here from P to this point, it's 5. Hence, it's a radius. And always remember, the radius of a circle will always be equal to each other. That's why we had our example in our previous video wherein we use an idealize of the same measurement. So the radius here is equal to 5. Doing so, we will be able to solve for this example. Arc length is equal to 25 degrees over 360 degrees times 2 pi, and then our r equal to 5. Now, a lot of people might be thinking, sir, why did you not substitute 3.14 for pi? It's much better this way, where we put our answers in terms of pi. Okay, I will go back to this later. To continue, 25 divided by 360, what would the answer here? Wait, I'm lagging. What's the answer here? Whoa, 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 whoa. Is this possible? 5, wait, I will do this manually. Please don't judge me. So I'll put first 5. I'll simplify again. Wait, what? I'm lagging, bro. Wait, wait, wait. Yeah, it's not. It's 5. It's 5. Yeah, 5 over 360 divided by. Oh yeah, yeah, yeah. I realize now. Yeah, don't mind me. I'm so sorry. 25 degrees over 360 degrees. 2 pi 5. So 2 times 5 is equal to 10 pi. Then if you multiply this, you will have 250 degrees over 360 degrees here. Pi. How did that happen? 25 times 10 is 250. So the answer here is S is equal to 25 over 36 pi. So meaning our arc length or S is 25 over 36 pi, or as read, or is read as 25 over 36 in terms of pi. That's how you read it. By in terms, it means pi serves as our variable in this example. So that's how it works. Sorry if I lag a little there. I don't know if I'm going to edit that out, but anyway, let's go with another drill. We're going to apply some of the cases. In this one, I'm going to skip this, but I just want to emphasize this one again. Please remember, you get semicircles when you have diameters. You have here diameter PS and QT. So PS. So you have one diameter, one semicircle here, one semicircle here. Then next you have QT, which is me probably. I'm just kidding. So you have QT here. So you have a semicircle from QRT and QPT. That will help you a lot in, again, solving, which is for later. Let's go to the next one. Yes, this one right here. Okay. So in here, it's specified a lot of things, and there are things here that you have to remember deeply. So first off, it says that we have circle A because that's the center. We have diameter PS and QT. We have RA and QT being perpendicular to each other. Always remember the symbol for perpendicular is that, and it results to 90-degree angles. That's why there's a box here. So this is 90 degrees. So a technique that I would like to share to you guys is, as much as possible, you put the measurements inside the circle. Write legibly for that one so that you won't be confused. So you have 90 degrees for QAR. Hence, we all know that RAT or RAT will also be 90 degrees. Because again, RA and QT are perpendicular to each other. So this will make sense later. So SAT is 20 degrees. Why? Because again, the arc is 20 degrees and this is a central angle, therefore they have the same measurement. And again, we do put degrees here, but when you have M angle SAT, we should just write 20. Next is RAS. RAS, so again, RA and QT are perpendicular to each other, they form a 90-degree angle. If SAT is 20 degrees, all you have to do to get RAS is 90 minus 20, and the answer is 70. So this one right here from RA, that radius, to AS, the angle they formed will be 70 degrees. Okay, next is QAR. Well, it's obvious QAR is 90 based on the box. PAQ. Now, this is one thing that I would like you guys to remember. PAQ and SAT are what we call as vertical angles. Vertical angles in this example is angle QAP and angle SAT. They are vertical angles because they were formed when we have two intersecting segments. And always remember, when you have vertical angles, it makes their measurement congruent. So QAP is going to be 20 degrees also. So, or PAQ, that's 20. So for PAR, arc addition postulate, you will add the measurement of PAQ and QAR. 20 plus 90, 20 plus 90, that's 110. Next, PAT. So since PAQ is 20, and always remember, again, the diameter helps us identify a semicircle. So 180 minus 20, you will get 160. So PAT is 160. So that's how it works. Okay, let's continue. Now we're going to find the measurement of the arcs. It's kind of similar thing. Now, again, the measurement of the arcs again is based off of the angles also earlier. So if ST is 20, we already know that RS should be 90. Oh, sorry, 70. Why? Because RAT forms a 90-degree angle. So again, the relationship of the central angles and the arcs are really important. Don't forget about that. So 90 minus 20, you get 70 degrees or 70. Okay. Next, QR. QR, this is related to that central angle equal to the arc. It intercepts. So QR is 90. Next, RP. RP is from R to P. So you need to get QP. We know that QP and ST again are congruent. 90 degrees. So again, why is it RP? Because it's two letters, meaning it should be a minor arc. So 90 plus 20. 90 plus 20. The answer is 110. Next is PRS. That's three letters. Hence, that means we're gonna have a major arc or a semicircle. Let's see. So PRS is from P to R to S. And as you can see, its endpoints is P and S. That is the endpoints of the diameter. This means that PRS is equal to 180 because it's a semicircle. PTR, let's see, where will that go? From P to T to R. Okay, so if PT and QP, if you add that, that will form a semicircle. That means PT should be 160 degrees. Because again, 180 minus 20 is 160. Why do we have to get PT? So that we can have or apply the arc addition postulate. 160 degrees plus RT. Kasi PTR guys, diba? So 160 plus 20, 180 plus 70. So you get 250. Okay. QTR. QTR. So QT is going to have, QPT is 180, then TR is 90, so you're going to have 270. Am I correct with that one? Yeah. QTR. It's going to be, wait, I'll erase this one so that I won't be confused and you guys won't be confused. So it's going to be QTR. It's going to be Q to T to R. So 90 plus 180, that's 270. So that's how it works. Now let's have one last drill. Now this time will be for arc length. Okay, so the formula for arc length again is S. Use the formula S equal to theta over 360 degrees times 2 pi r. And this given, if the radius of this circle is 9 centimeters, how long is arc QR? QR. Again, we already know this is 90 degrees, but we want to figure out its arc length. And your theta here is this. This is your theta for this example. For this example again. So in this case, we'll have arc length is equal to 90 degrees divided by 360 degrees times 2 pi. The radius is 9, so times 9. 90 divided by 360, you can simplify this given fraction as 1/4. 2 times 9, that will give you 18, so 18 pi. So this one right here, our arc length will be equal to 18 over 4 pi. But always remember to simplify your answers. S is equal to 9 over 2 pi. This is our answer for the first one. So now, how about number 2? Radius is 10 centimeters. And again, sir, sabi nyo all the radius are equal. Yes, it is. But again, these are two different situations. Okay? They're two different situations. It says if. So basically, it's an if kind of situation. So if it's 10 centimeters, and how long is arc ST? We all know that the reference angle is SAT, so it's 20 degrees. So that's all. S is equal to theta over 360 degrees times 2 pi r. S is going to be equal to 20 degrees over 360 degrees times 2 pi times 10. So S is going to be equal to 1 over 18 times 20 pi. So if you simplify this, you're going to get 20 over 18 pi, or S is equal to 10 over 9 pi. That's your final answer. So again, 20 over 360, divide it by 20, or simplify it by 20, you're going to get 1 over 18. And then 1 times 20 is 20, so 20 over 18. 20 divided by 18, again, you cannot do that, so you simplify it. They have a common factor, which is 2, so it's 10 over 9 pi. So that's how it works. And this ends the part 4, arcs, arc measure, and arc length.
And that's arc measure and arc length. So I decided to, somewhat lessen the hour long videos because I think I have time this week to edit a lot instead of just putting them in one video altogether. So yeah, why not, right? So if you guys learned anything, congrats, because I learned this like 2 or 3 weeks ago. Not kidding. I don't. We didn't have circles when I was in high school, and I think we did have it in college, but you know what I mean. I wasn't awake at that time. So, well, I hope you guys are awake now and are understanding these concepts. So please forgive me if I stumble a lot. But anyway, in case you don't see me, you'll probably see me in the next one wearing the same thing anyway. Good morning, good afternoon, good evening, and good night. Bye bye. Respect everyone.